Hey everyone, welcome back to MLWorks. In this video, we'll be discussing how to interpret a transformer pipeline for text classification. So for this tutorial, we'll be taking up emotion data set which has a pre-trained model called BERT, and we'll be using that specific model and interpret its predictions. So at the end of the day, what we'll do is, given an input query or an input sentence, we'll be passing that to a model and we'll generate a prediction. Now some of the tokens will be reacting towards certain emotion and some tokens to some other emotion. So we'll understand which token maps towards which emotion. Okay, so with that, let's get started with the implementation. So the first thing you have to do is to install transformers and SHAP, and you can also install datasets to load a dataset from here as if you want to replicate this example. So first, once the installation is done, you can just go ahead and import all the packages as mentioned here, and then we'll download a dataset from datasets.load dataset. Emotion dataset will download and split it into train and test, and we'll turn that into a data frame using pandas. So once that is done, what we'll do is we'll look at what is the data looks like. So we'll have on one side input sentences, on the other side we'll have the emotions. And let us understand here. So here that when I say input sentences, these are the input sentences I'm talking about, and these are the labels for each of those input sentences. So there are totally 6 different emotions that we are trying to predict, and those 6 are as mentioned here. So the idea is some of the words may tend to map to certain emotion, and some words can tend to map to certain other emotions in the same sentence. So we have to understand how the whole sentence at the end of the day, okay, gives you a final prediction. Okay, so let us understand how to load the model and how to create a pipeline first. So first what we do is we take a tokenizer from Hugging Face transformer. So we'll be using this specific tokenizer, and tokenizer is used for processing your text into a format such that it is usable by the model. So once tokenizer is created, what we do is we load the model using auto model for sequence classification, and we are taking the pre-trained model which has been trained on this specific data set, and we are mapping it to CUDA for using the GPU. Once we have our tokenizer and model, we turn that into a pipeline as mentioned here. So this is our pipeline at the end. Now it is quite simple when you want to use this pipeline in SHAP. What you just have to do is just take this pipeline and pass it to the explainer. And under the hood, what it does, it has specific modules for loading the pipeline for transformer and similarly for tokenizer as well. Okay, it will use those specific modules to understand this pipeline. Okay, so let me load this model first, and then we'll be creating our explainer. Now explainer is created. Now what we have to do is we have to pass in the input. So this basically the explainer understands how your input sentence is fitted to your labels. Okay, so with that understanding, what we do is we pass in our input. Okay, here we are sending 3 samples and we are generating the SHAP values for those 3 samples. So the 3 sentences these are the 3 sentences. So it is one seems like, so if I just want to look at the label as well, I think we can see it here, the labels 003. So it is sadness and anger. So let us understand how the tokens map towards a specific emotion. Okay, by reading the SHAP value for the index 0, which is this for this specific input sentence, how it is generating the final prediction. Okay, so let me run this. So it is already highlighted, sadness is highlighted for this specific input sentence. The prediction is sadness. Now the words that contributed towards this emotion is humiliated. Okay, it contributed around 0.855, and the final score for that specific class is 0.996. The other words which contributed are, if I just click this one, it has negatively impacted, the field word has given the negative impact on this final prediction, and didn't has given a specific positive impact in terms of final prediction. Okay, and this is the base value plus humiliated, all these gets added and it generates the final score of 0.9964. Now this is for only sadness. Okay, because now when you're predicting it, it also has some amount of probability on other classes as well. So to see that, what you have to do is just hover over those specific class and click them. Okay, so here if you see, we have, instead of only pink line, we have both pink and blue. Okay, so joy is kind of a positive sentiment, and here this humiliated is kind of normally used for negative sentiment. So it has negatively impacted, and while the word feel has a positive impact with respect to the class joy. Similarly for other classes you can see by clicking them. Okay, so this is for one specific sample. If you want to do it for a bunch of samples together, you can just give the index or the range of index you want to look at and then just plot it. So for plotting you have to just shap.plots.text. So it will give you those plots. So this is for two sentences, the second and third one, and this is the second sentence. So for these two samples, for this sample, it is, the prediction is sadness, and its final, if I just click it here, you will see the score is, confidence score is 0.99. It is probability score. And then here the final prediction is anger, and the score is 0.991462. Okay, and we cannot clearly see what are the words that contribute towards that such emotion. Okay, so right now we are just looking at the whole sentence and all the classes simultaneously. Okay, now we'll understand for specific class what are the words, or what are the words that get triggered. So this is again for the first three samples. Okay, so here for the anger, all these words were active or contributed towards it. Okay, so if I go here, all these are like, if we have seen earlier, these first two samples, okay, I didn't feel humiliated. On the second one, their prediction was sadness, the emotion was sadness, and for the third input sentence, the emotion was anger, and we can clearly see the words that are like triggering those kind of emotions. Okay, this is for identifying for a specific class what are the different words that are getting mapping towards that specific emotion. Now we can also, what we can do is, we can understand for all the sentences what is the words, what are the different words that are contributing towards a certain emotion. For example, okay, if you plot this bar plot, okay, for a joy, you calculate the mean of the SHAP values for all the tokens. Okay, and we'll see a bar plot here. Now for joy, okay, these words, the blue one represents a negative emotion, and they have given this kind of plot here. And for joy, they have pink one, all these have positively impacted towards joy. Okay, now let me just sort this. So we'll see much more relevant results. Okay, for joy, okay, the negative impact is done by humiliated, hopeless, greedy, feeling wrong. So all these words have massive negative impact in terms of joy word. And when it comes to, let me just flip this one as well. When it comes to positive impact for joy, okay, for the class joy, hopeful is one of the positive words, awake, feel, cares. So all these are positive impact for the class joy. Okay, if what it means is, consider you have an input query or input sentence that is coming in. If it contains any of these words, there is a very good chance it will be moving towards joy class, because they contribute a certain amount to this specific class. We have seen till now it's only in terms of probability score between 0 and 1. But what we want to do is, we also want to understand the log odds of these tokens. Okay, so for that what we can do is, in transformer pipeline we can pass it rescale to logits to true. Okay, this will give in terms of logits instead of probability score at the end. So if you look at here, now previously we saw it is 0.996 or 0.97 something, right, which was the final probability score for the specific class. And here now what we are seeing is the logit score for each of those final class and what are the corresponding logics for each of the tokens. Okay, so this is for this specific input, which is I didn't feel humiliated, and we are seeing the logics value and how they contribute towards the final prediction. Similarly for other inputs also we can view. Now this is with respect to understanding how each of those words logics helps you in understanding how the prediction will take place. Now we can add and subtract values and understand which words will contribute more. Okay, so that also can be done with this logics. Okay, now this is till now what we have seen is for text classification, okay, which is a very simple model. Okay, now if you want to do text to text generation, for example machine translation from English to Spanish or English to French, you can use SHAP for it, and you just have to load the specific model. So first what we have to do is we just what we have done earlier, just load the packages or import the packages here, auto model for sequence to sequence classification, auto tokenizer, and import SHAP, and the corresponding models which is for English to Spanish here, and we are just moving it to CUDA, the model, and then we are taking in one input. In this scenario the transformers have rapidly become the model of choice for NLP problems. Okay, so this is our input. Now once we have taken our input and loaded the model, what we want to do is we just have to pass in the model and the tokenizer to the explainer. Since we didn't create the pipeline here, we can directly pass both the model and the tokenizer. And then what we do is we just look at the fixed context of 1 for the specific input. Okay, let me run this here. So this will generate the SHAP values for the things that got translated and how they relate towards the input text that we have given. Okay, so let me see the SHAP value here. So this is our input, which is transformers have rapidly. Okay, and this is in turn what maps to the translated version of it and how those words are like mapped. For example, this is the Spanish version for transformer. If I click this, okay, it is showing what it has contributed towards, and if I'm clicking this specific value or this specific token, it is mapping towards this specific word in the English language. Similarly for this specific word, what is the English translation? For this specific word, what is the English translation? And we are seeing what are the different values for each of those. Okay, recurrent and networks. So yeah, this is one of the way to understand how when you translate from one language to other, which word contribute towards which word and whether it is correct or not. And if it is wrong, okay, then you might have to update your data set in such a way that it is mapped correctly. Okay, so yeah, we have understood in this video a bunch of things. One is how to understand which words contribute towards a specific emotion in a text classification problem, and then we looked at text to text generation for language translation, and we understood how one word translates to other words and how they contribute towards each other. Okay, so with that I'll conclude this video. Thank you for watching.